All right, welcome back, fellow statisticians. What we're going to do now, we're going to go over question number 7 from the homework, and you will do questions that are very similar to this question. So let's run through this one. Alrighty, so we have our smoke detectors, which we spoke to in the beginning when we talked about sampling distribution, and this question is about them. The average lifetime of a smoke detector that a company manufactures is 5 years. Now, this is very important that they give us this information in months because the standard deviation is also in months, okay? So these are the things that are given about our population distribution. And then they ask us to find the probability that a random sample, okay, of 30 detectors is going to have a mean lifetime between 58 and 63. Well, note that nobody tells you here that this is a normal distribution. Well, they don't even have to do that because guess what? This happens to be a sample size of 30. So it doesn't matter from what kind of distribution it comes. The central limit theorem applies here. And you can actually say that the mean of all the sample means is actually going to be the mean of the population, which is going to be 60 months. How wonderful is that? The standard deviation of all the means of the samples of 30 is going to be 8, right, divided by square root of 30. I'd pause here and calculate and see if you end up with 1.46. That's what I ended up with. And now they ask me, what is going to be the probability that it's going to be between 58 and 63 months? Well, I need to know where is 58 months. I know it's on the left, but I don't know exactly where it is. And I know 63 is somewhere here. So let's do this step by step. Let's just stick 58 somewhere here. This is going to be my first z-score, this 58, right? This is going to be my z1. How do you calculate that? Well, I'm just going to take my 58 and I'm going to subtract it by my mean, and I'm going to divide that by the sample standard deviation, 1.46. What are you ending up with? I am ending up with negative 1.369. I'm going to round that to 1.37. So far, so good? Okay. My second guy here is going to be my second z-score is going to be somewhere on the right side. I don't know exactly where it is on the right side, but it's going to be somewhere here. And this is my z2. And I know that it has to be 63 months. So 63 minus 60, okay, it's on the right side, divide by my sample standard deviation, or standard error we call it as well. And go ahead, calculate that. And do you end up with 2.054? I'm going to round it to 2.05. And I'm interested to be in between those two z-scores. This is the area of interest. Now remember, your z-chart only gives you the left side of your z-scores, right? So if I am interested, if this is what I want, if I would like to know the probability that my z is going to be trapped between negative 1.37 and 2.05, I would have to take the probability for 2.05. Z is less than 2.05. And I would have to subtract from it the probability for Z being less than negative 1.37. Okay, go ahead, take your charts, take your Z charts, and look up those probabilities, right? Pause the video if you need to. Okay. So the probability for having anything up to 2.05 standard deviations is going to be 0.9798. The probability of being of this area, right, up to negative 1.37 is 0.0853. Now, this is the area that I don't need. This is why I'm subtracting it. Subtract those two, and you're going to end up with 0.8945, or roughly 90% chance that our smoke detectors are going to have a lifetime, if we took 30 of them, are going to have a lifetime between 58 and 63 months. All right? Questions, let me know.